Good evening, student. Today we discuss about IIR filter designing. So in IIR filter designing, I already told you, it's indirect method. So first you design the analog filters, and then you have to transfer to digital filters. So you transfer digital filter to analog filter digital, HFS to HFZ. These are two methods is to convert HFS to HFZ. The first method, impulse linear method, another is binary transformation method. First, we see what is binary transformation method. See one by one. Okay. In designing IR filter, we are using for binary transformation technique method. Let us consider system functions of analog filter. H of s equal to b divided by s plus a. So numerator is called the zeros, so there is called poles s plus a. So this is called the differential equations. So describing every equation, you have the differential equation expressed as h of s equal to y of s divided by x of s equal to p divided by s plus a. I modify this equation. So now we'll take this equation, refer this equation. You have to cross multiply this equation. S into y of s plus a into y of s equal to b into x of s. So now we'll take this equation to inverse Laplace transform on both sides. We'll get this dy by dt and dy of dt plus a into y of t and b into x of t. So now the equation integrating the above equation between the limit is x of t minus t and n of t. You have to integrate this equation. So you have to integrate. So you have to simply purpose, you have to apply the trapezoidal rule for numerical integration expression for above the equation. So you have to this is a trapezoidal rule. So the limit is nt minus t is nt, a of t dt. This is solution. The answer is t by 2, a of n of t plus a of nt minus t. This is a solution. Same you have to apply this equation. So after this, apply this solution, the equation, therefore we get y of n of t minus y of nt minus t plus a t of t divided by y of nt plus a of t by 2 y of nt minus t equal to b of t by t into x of nt plus b of t by 2 x of t minus t. So after that, we will take this equation, take z transform. Take z transform this equation, y of z equal to 1 minus z inverse plus a by t by 2, 1 plus z inverse y of z, and b by t equal to 1 plus z inverse into x of z. So you have to rearrange this equation. You have to find a system function of digital filter. So you have to find h of z. H of z is nothing but y of z by x of z. You have to rearrange this equation. Finally, you got the expression b equal to 2 by d 1 minus z inverse plus 1 plus z inverse plus a. So this is nothing but this s value, s equal to 2 by t 1 minus z inverse 1 plus z. This is called s value, or other form is called as 2 by t z minus 1 or z plus 1. This is called the relationship between the s and z domain is known as, this is called bilinear transformation equation. This is called the relationship between s and z domain. So let us define z equal to r e power j omega. Already S domain is called as real and imaging part, omega plus j omega, sigma plus j omega. Then the relationship between S and V can express it as follows. So this equation substitute z equal to r equals j omega. We substitute and then simplify it is complex multiply numerator denominator. After that simplify, you got real and imaginary part. Real part equal to the 2 by t r square minus 1 r square plus 1 2r sin omega. Imagine part equate this equation, you got this 2 by t 2r sin omega r square plus 2r sin omega. So now you have to apply the condition r is less than 1 means sigma is also less than 0. R is greater than 1 means sigma is greater than 0. When r equal to 1 means the sigma equal to 0. Now we got the relationship between this analog and digital. Suppose I have digital means you take this cross multiple, take inverse, is the omega equal to tan inverse omega t divided by t. So in binary transformation, you also got some effect is called warping effect. That effect, how come we get the warping effect? We know that analog frequency equal to 2 by t tan omega by t. For small omega value, for an omega equal small means assume that this is omega small value is nothing omega by 2. Therefore, omega equal to that value in the small value, you got only this omega is small value. This is omega by t only. The small value will got only. You cross multiply this digital omega to analog with t. For low frequency, the relationship between omega and omega is linear. This is analog, this is digital, this is linear. Digital filters, same amplitude respond at the analog filter. But high frequency, the relationship is non-linear. So distortion also introduced in the frequency scale of digital filter. This is called as warping effect. How can avoid this warping effect? You have to do pre-warping. So you have to do pre-warping. You have to avoid this warping effect. So you see this effect of magnetic response. This is called digital response. This is analog response. You have to transfer this. This is not the transfer the response. Yeah. This is a magnetic effect of magnetic response. Similarly, the effect of phase response. This is for analog, this digital, this is analog response. This is a non-linear response. So that purpose, this is called warping effect. How can avoid this warping? You have to do pre-warping. What is pre-warping? Pre-warping can be eliminated by, okay, warping effect can be eliminated by pre-warping the analog filter. To find the warping of analog frequency, we have the formula. This is the pre-warping formula. Omega t by t tan omega by t, or passband frequency equal to 2 by t tan omega p by t, or stopband frequency equal to 2 by t tan omega p by t. So in this way, you have to avoid the pre-warping. Thank you.